Yes, members? Members?
Yes, teacher.
Please, let's continue. Let's what? Continue. Cynthia, what are you mourning? Why are you putting your hands like that? Are you mourning? Members, are we together so far?
Yes.
Very good. Lynette. Lynette.
Shall let me ask you a question before we proceed?
Please ask me. Ask me. I'm willing. I'm willing. You ask me.
Yes, teacher.
Yes.
Yes. Why is it that
Teacher.
when, like,
Please, someone is asking question, please. Answer.
when like you're standing where there is light at night, you're not able to see that person in the dark, but the person in the dark can see you. Why is it that like that?
Oh, that is a very good question. Members, this is asking why is it that, take for example, at night, when someone, take for example, they flash a torch on you at night, you will not be able to see that person who is flashing light on you. That one is example when they flash the light direct into your face. Direct into your what? Into your face. Remember, members, we said for you to be able to see anything, we are able to see is because of light, not so? Members, we are able to see is because of what?
Light.
Because of light. And our human eyes, there's a certain amount of light that we must control for us to see. Not that every light that we, not that when light enters our eyes, we must see. Our human eyes, they are controlled in such a way that there must be limited amount of light that enters into our eyes and is controlled. We know what controls the amount of light. Not so? So the amount of light that is falling on the retina, the human eyes, is controlled. So when you leave, when excessive amount of light enters your eyes will blacken up. Are you together, members? Are you getting me?
Yes.
Are you getting me? Your eyes will what?
Yes.
That one means when excessive, that's why we always say that it's not advisable to expose yourself to light with high intensity. Okay? That's why you see that light we use in the bathroom should not be the same as the light we use in the sitting room. The bulb that we use for security purpose, the one we use outside for security purpose, is not the same. The intensity, they must all keep varying. That's now that one brings us to power. We refer to them as the rating of that bulb. You see, the one that you put for security purpose outside is very bright, not so? Because from outside there, we shall not be exposing ourselves a lot. Because our human eyes are created, you see, God is very wise. God created our human eyes in such a way that it can be protected. We must protect our human eyes. How do we protect it? There must be limited amount of light rays that is entering into our human eyes, or that is focused onto the retina, so that the image is able to be formed. So that now when excessive amount of light enters the retina, which cannot be controlled, so which means large amount of light will enter into the retina. So the image will not be focused on our retina. You get? Instead, the image will just see a blur. The right word to use is a what? Is a blur. You can't see clearly. Let me hope I was very clear on that. Have I answered your question?
Yes, sir.
Very good, very good, very good. Now let's write definition. What is rectilinear propagation of light? When they say define rectilinear propagation of light,
This is the process for which light travels.
is a what? Senior series who are here. Alexandra, what is the rectilinear propagation of light? I remember we discussed those things. What is rectilinear?
Light.
Is the what?
Property of light that travels in a straight line.
Good. We said rectilinear propagation of light is phenomenon, is a phenomena.
So let me try.
Now someone has already given us the answer. Okay? Rectilinear propagation of light is a phenomenon or process by which light travels in a straight line. Is a process or a phenomenon by which light travels in a straight what? In a straight line. Or someone will say is a study of light traveling in a straight line. Are we together, members? Members, are we together?
Yes.
Jordan, are we together? Lucky, are we together?
Yes, sir.
Yes, teacher.
Okay, you repeat for us. What define rectilinear propagation of light? Define it for us. Repeat it for us.
Rectilinear propagation of light is a phenomenon or process by which light travels in a straight line.
Even you are putting the word stroke.
Teacher, yeah.
You say rectilinear propagation of. You just pick one of these two. Don't use all of them. You say rectilinear propagation of light is a process by which light travels in a straight line, or is a phenomenon of light traveling in a straight line. Full stop. Are you together?
Yes.
Yes. As simple as that. Don't cram. Don't what? Don't cram. Now, the person who did this experiment to show that light travels in a straight line, that person was called Sir Isaac Newton. Is Isaac who? Newton. And for him, he was wondering. I want to show you a video. Can I show you a video, members?
Yes.
Now, I believe what is in the notes there, you can copy and read through, not so? Not so? Members?
Yes.
What is in the notes there, you can read and you can go through after watching the videos, not so?
Yes.
Now, let me show you the video. Let me show you a video. Let me show you a video here. Numbers, wait a bit. I want to show you a video. Please don't copy my thing, eh? YouTube, let's go to YouTube. Members, are you able to see my screen?
Yes. Yes.
That is good. Rectilinear propagation of light. Good. You can see it's already there, even rectilinear propagation of light. Let me get the good one. Just in a few minutes, a good one.
He's not gonna put us animation. Like cartoon.
Oh, who is that one? Who is that one? Let's watch this one. Members, that one is still advert. That one is advert. Members, are you following?
Yes.
Members,
Yes, teacher.
yes. So the cardboards, what you are seeing there, those are the cardboards. All of them must be in a straight line, and light must come from a source. Remember we said when light is produced from the source, so there must be the source of light. So you watch closely, the source of light is going to use. Members, are you seeing that?
Yes.
Okay. Now let's go back. Let me show you another one. Let me show you a good one. Let me look for a good one. Where is it? There is this one I wanted to show you so that you can see it clearly. Is here. Let's also watch this one. Members, are you seeing that one?
Yes, teacher.
All right. Members? Members?
Yes, teacher.
Were you
Yes, teacher.
following? Were you following?
Yes.
Were you hearing?
Somehow.
No.
Yes?
Somehow.
No.
Somehow.
Been hearing.
But at least you are following the video, right?
Yes.
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 Okay, that's
Yes.
the most important thing there. Members?
Yes, teacher.
Yes, members. Huh?
Yes, teacher.
So that is that short clips. At least I've shown you what we are discussing today. Okay. So I think you will never forget what a light ray is, what a beam of light is, the properties. Now, that experiment you are seeing, I think you can copy, you can read through, and then because you have watched the videos, you have understood the process. So what you do, you get 3 cardboards, A, B, and C, and you arrange them with their holes. The holes, when you are creating the holes, like you have seen from the videos, they must be of the same diameter. The hole must be of the same diameter and with the same height. They must be at the same level. Are you together? They must be at the same what? Level. Then you arrange them in such a way that they are in a straight line. Then there must also be a source of light. There must be a source of light, which you can use a candle. From the video, we are using a candle. You can use a lamp, any source of light that we have looked at. Okay? Then you set them in such a way that they are in a straight line. Then for you as an observer, you come at point C, depending on how you have leveled your cardboards. Depending on how you have leveled your cardboards. Then you view through, or you see through the holes. You see that you're going to be able to see the light rays from the light source. From the light source. But when you displace one of the cardboards, you will not be able to see light. And that one proves that light travels in a straight line. That proves that light travels in a straight what? Members, is it clear?
Yes.
Now, what are the applications? What are the applications? What are the applications? Members?
Light travels in a straight line.
Yes, I want to show you something. I want to show you something, but I need to write, okay? I need to write. This is taking time, is not connecting. Be patient with me, please. Members? Hold on a bit, hold on a bit. Let me connect my camera so that you'll be able to see what I'm writing. So is there any question so far on what we have looked at? Is there any question so far? Like on the experiment on that to show that light travel in a straight line. Is there any question on that? Members, can you talk to me, please? Members, is there any question on that?
No, teacher.
Okay. All right. Now, when you look at what are the applications, subheading applications, application of rectilinear propagation of light. Where are they applied? Applications, applications, applications of rectilinear propagation of light. Applications. Subheading applications, applications of rectilinear propagation of light. We say that light travels in a straight line. What effect does it have? What effect does it have? Okay, when you block off light from one direction or from one point, what effect does it have? So the thin propagation of light helps us to understand certain concepts. And one of these concepts is, one of the application is shadows. We are able to form shadows. Shadows is able to form is because of rectilinear propagation of light. One is shadows. Then the second we have is eclipse. We have eclipse. We have is eclipse. Then the third one is a pinhole camera. A pinhole. A pinhole what? Cameras. Members, are we together?
Yes.
Yes. Those are the three applications of rectilinear propagation. So when they ask you what are the applications of rectilinear propagation of light, there are only three. We have shadows, we have eclipse, then we have a pinhole cameras. Now let's start with the first one. Let's start with shadows. Subheading. I know our time is running out, but we shall just look at the few components under shadows. Let's look at shadows. We are saying a shadow is there. You can see it from your screen there. A shadow is an area or region, where light cannot reach. A shadow is an area or a region where light cannot reach. Or you can say a shadow is a region of darkness. Form when an opaque object obstructs the path of light. That's also another definition you can give. You can say a shadow is an area or a region where light cannot reach. So when light cannot reach, it will create a region of darkness. So you can say is a region of darkness formed when an opaque object obstructs the path of light. Full stop. In another line. A shadow or shadows are formed because light travels in a straight line. Light travels in a straight lines. Subheading, type of shadows. Subheading, type of what? Shadows. We are saying, let's write this statement first. The type of shadows, formed depends on the size of the source of light. It depends on the size of the source of light and the distance between the object and the source of light. Full stop. Then another line. There are two types of shadows. And these include members, are you following me? Are you following me, members? Yes. Please make sure you're following, because these things I'm just writing over it. And this includes, there are two. One is called umbra. And the second one is called Penabra. One is called Ambra. Then another one is called what? Pena what? Nabra. So this one is total. Total what?
Darkness.
Total darkness. Then this one is partial.
Darkness.
Partial darkness. Yes. That is partial darkness. Hello, Kenge.
Yes, teacher.
Now you know the type of shadows, right?
Yes.
What are they?
Ambra and penumbra.
Ambra and Penabra, okay?
Teacher, I have a question.
Yes, please.
Okay.
Yes?
Me first get it up. I'm not seeing where I wrote it down.
Mm-hmm.
Okay, is it true that if one wants to go to the sun, like to travel into space and go to the sun,
Yes.
like you can go during the, okay, the question goes like this, eh?
Yes.
Professor Mesa thinks he's clever, so he decides to go to the sun, to travel to the sun during an eclipse of the sun. So can it be possible?
It's not possible, members. It's not possible. And no, you cannot dream of going to the sun. Why? Because of the temperature alone. Okay? Scientists are trying all their possible means to go to the what? To go to the sun, but it's not possible. Because materially, there's no way we can design a system that can, because actually going just near to the sun, which means I don't know what type of materials we will use to make that plane or that aircraft or that airspace. Because the material must be the one with high melting point, and those materials are not easy to get. The only metal with high melting point that scientists have discovered is what we call, that material is called tungsten. It's called what?
Tungsten.
It's called tungsten, and it's very rare. It's very rare. It's not easy to get it everywhere. So most of the spacecraft that you see, they are made of materials have high melting point. Because for you to melt a tungsten, you need over how many? 37,000 joules of heat. You get it?
Yes, but teacher.
Yes, but the material you need to go to the sun, that material we have never discovered it, please. We have never discovered it because the temperature is very high.
But teacher.
Yes.
Even if he went during the eclipse of the sun, he can still die.
Now, what we call the eclipse, okay? When we come to the eclipse is a phenomenon where there's the sun, the moon, and the earth, the three planets, they appear to be in a straight line. It does not mean that they are close to one another, but it's a situation where they appear to be in a straight line. Then when they're in a straight line, they try to create, that effect is visible. The effect is now what we see is what we call the eclipse. And we have different type of eclipse. We have what we call the lunar eclipse. We have what we call the annular. Okay, then we have what we call the eclipse of the moon. You get? Are you getting me?
Yes, teacher.
Yes, we shall discuss that one at length when we release eclipse. But it's not possible to go to the sun. It's not possible. Practically, it's not possible. Because even Mars, just going to the Mars, okay, the planet Mars, it took scientists many years to discover which material they can use to make a spacecraft that can go to the Mars. Are you seeing that? Because the Mars itself is too hot. But it's not the same as sun. Sun is extremely hot. Are you together?
Yes.
That's why sometimes when I'm having conversation, sometimes I tell people that I think God is in the sun because He doesn't want to be disturbed. Because if people are discovered, people can go to the moon, People can go to the Mars. People have discovered other planets like Jupiter. People have discovered like other planets like Venus. People have discovered so many things, but it's only the sun where people have no detail about it. Okay, you get my point. So sometimes,
Yes.
sometimes I'm forced to reason that maybe God is in the sun because he doesn't want to be disturbed. You get my point?
Yes.
Yes. Let me know if I've answered your question, please.
Yes.
Now, okay, are you convinced? Are you convinced?
Yes.
Yes, my work here is to convince you and to make you understand science, okay? How it works, okay? Now, members, hello, are you getting me?
Yes, teacher.
Yes. Now let's write the subheading, shadow formation. Shadow formation. The one you're seeing on your screen. Shadow formation. Shadow formation. Shadow formation. Shadow what? Formation. Can you write it down, please? That one is on your screen. I'm not going to write it now. Members, are you writing? Write this statement down, please. Shadow formation. You're saying that a point source is a very small source of light, full stop. It can be obtained by placing a cardboard with a small hole in front of a lamp, as shown below. As shown below. But you have these books. You have these notes, right? Members,
Yes, teacher.
our time is so limited now. I will not be able to explain all those now, but we shall explain it later on Monday when we meet again, okay? Right together. Because we have two sources of light here. We are interested in two sources of light here. There's what we call a point source of light. Then there's also, it's different from what we are looking at shadows. For shadows to be formed, there's a point source of light, which means this one is a small source of light. Then we have an extended source of light. An extended source of light. Okay? So different source of light give us different shadows. Like a point source of light give us what? It form only what? The umbra. Then extended, it form both. It form both umbra and what? And what?
ISAIAH.
And penumbra.
ISAIAH.
Narokenge.
Yes.
Narokenge.
Sorry, teacher.
Yes. So we shall look at how to draw these shadows when we meet again. Are you together, members?
Yes.
Yes, we shall see how to draw them. But a point source of light give us umbra, then extended give us umbra and penumbra. Then we shall look at how to draw them when we meet again. Okay?
Yes.
Is there any question so far? Is there any question?
Yeah.
Is there any question?